So in this section of notes, we're going to look at and talk about bonding. Really, we're going to focus on the bonding that we care about for biology, not all bonding, but specifically what is important for us as biologists. So atoms, remember from the last set of notes, are going to behave in a way that's going to be aimed at trying to make them the most stable. And so what that means is they want to have their valence shells either be all the way up to 8, or if we're talking about the first shell only holds 2. So either being full at 2 or being full at 8. So they're either going to increase or they're going to lose electrons in order to get to be stable. A chemical bond is the force or of attraction that holds the two atoms together because of a rearrangement of the electrons between them. So basically what this means is you've got this force that's created when we move electrons around between two atoms, and that force is going to hold the two atoms together. So let's start with ions. Atoms with 5, 6, or 7 valence electrons, are they going to want to gain or lose electrons? Answer that in Edpuzzle. If they have 1, 2, or 3, are they going to want to gain or lose electrons? Again, answer that in Edpuzzle. Ultimately, if we're looking at something with 5, 6, or 7, they are going to gain electrons. And so they are going to end up being negatively charged atoms because they're going to want to gain electrons. If they have 1, 2, or 3 electrons, they are typically going to lose their electrons and become positively charged. So when we get atoms gaining and losing electrons like this, then they become what are called ions. And ions is just a fancy word for a charged particle. These charged ions, because they're positively and negatively charged, are going to actually be attracted to each other to form a bond. So just a little bit of humor. Two atoms talking together. One says to the other, "I'm about to lose an electron." And the other says, "Are you sure?" And the first says, "I'm positive." Ha! It's funny. So an ion is an atom or a group of atoms that has an electrical charge because it's going to either lose or gain electrons. When they lose an electron, they're going to become positively charged because they've lost a negative charge, and so now they have more positive protons than they do negative electrons. So their overall charge becomes positive. When the atoms gain electrons, they now have more negatively charged electrons than they do positively charged protons, so now they become negative. So this is a classic example of an ionic bond. You've got a sodium atom, which has 1 electron in its outside shell. Then you've got chlorine, which has 7 electrons in its outside shell. Neither atom is what I call a happy atom. Again, I'm a biology person. I talk about happy atoms. So sodium's not happy because it has this 1 random electron in its outside shell. It's a very lonely electron. It doesn't want to be by itself. Chlorine is unhappy because it's got 7 electrons. It's not full yet, and it wants to be full. Now, the interesting thing is that sodium, in its natural state, is actually a silver metal. And it's soft enough that you can cut it with a knife. And here's the cool part. If you put sodium in cold water, it actually explodes. Chlorine gas is extremely reactive. It's highly poisonous. It's deadly. It was used in World War I as a weapon. So if we take sodium, we take chlorine, and we put them together in a solution, the sodium's going to give up its electron to chlorine. That's going to make sodium be positively charged. Chlorine's now going to be negatively charged because it's got an extra electron. And we get what's called sodium chloride. Now here's the crazy part. This metal that explodes in cold water, this highly reactive poisonous gas, when we combine them together, we get table salt. So the interesting thing is that when we combine atoms and elements in different ways, the properties that we get can be drastically different as well. So salt is abbreviated as NaCl, and this is really what we're talking about here's table salt. Sodium becomes positive because it gave up an electron. Chlorine becomes negative because it took in an electron. So they bond together because they're oppositely charged. And everybody's heard the old saying about opposites attract to each other. So the negative charge is attracted to the positive charge and causes the two things to stick. So ionic bonds form as a result of the attraction between positive and negative ions. Any compound that consists of negative and positive ions is what's called an ionic compound. So chemical formulas are how we abbreviate these things. They're combinations of symbols that shows the ratio of elements in a compound. So in this formula, sodium and chlorine are called sodium chloride. They're salt. So typically what we see is the fact that there's no subscript here means that there's one of that atom. So in Edpuzzle, answer the question of how many sodium atoms are there and how many chlorine atoms are there in sodium chloride. Subscripts are going to be used to tell you the ratio of the atoms. So when we're looking at calcium carbonate, so that's what this atom is here, this compound is here, is calcium carbonate. Okay. Calcium carbonate is used, it used to be used to make chalk, but it's also used in seashells for organisms. So here's my question. Again, Edpuzzle, how many calcium atoms are there? How many carbon atoms are there? And how many oxygen atoms in calcium carbonate? Ionic bonds are one type of bond that we use, but not every atom wants to completely give up responsibility for its electrons, and not every atom wants to completely take on the responsibility of electrons. And so sometimes we have what are called covalent bonds. These are bonds that are formed when atoms actually share their electrons. This is the force that holds electrons together, is the attraction between the two nuclei for the shared pair. So I'm going to draw for you, I'm going to put in a slide and draw for you water and explain how water shares electrons. And then I'll put in another slide and draw oxygen. Oxygen shares two pairs of electrons, and because it shares two pairs, it's going to form what's called a double bond. So we're going to start with water. Water, remember the formula is H2O. So if I have an oxygen atom in the center, oxygen has 6 electrons in its outside shell. So what I'm going to do is I'm going to draw my 6 electrons, and I'm going to leave space on either side here for me to show other electrons coming in. Now hydrogen has only 1 electron in its outside shell. The interesting thing about hydrogen is hydrogen can either give up its electron entirely or share its electron, and really what it's going to do is dependent on the difference in size between the two atoms. If you've got a really big atom that's trying to bond with hydrogen, typically hydrogen is going to lose its electron. But if you got something that's fairly close in size, then hydrogen will share. So in the case of oxygen and hydrogen, they tend to share electrons. And so what's going to happen here is these electrons are going to go back and forth between the hydrogen and the oxygen atom. And so the way we show that is we draw a circle around the 2 electrons. And what the circle means is that this electron is going to spend time with hydrogen and it's going to spend time with oxygen. This electron is also going to spend time with oxygen, but it's also going to spend time with hydrogen. This pair of electrons is going to spend some time with oxygen and some time with hydrogen. We're going to talk in a lot more detail about water molecules and their specific sharing of electrons because it's a little bit unique in the next set of notes. So let's talk about oxygen gas for a second. Oxygen gas is O2. So what this means is that you have 2 atoms of oxygen in your molecule. So again, my oxygen atom has 6 electrons in its outside shell. Okay. So I'm going to draw my other oxygen atom in blue just so that we can tell which oxygen atom is which. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need to put another one over here. That's fine. And I'm going to put another one over on this side. Okay. So what I'm going to do here is neither oxygen atom has 8 electrons in its outside shell. So neither is happy right now. In addition to this, neither oxygen wants to fully give up 2 electrons or take on 2 electrons completely. If we fully give up or fully take on, then we're going to end up with 1 atom that has a full outside shell and 1 atom that only has half the number. So in this case, we definitely need to share our electrons. And so what we're going to do is we're going to draw a circle around these 2, showing that that pair of electrons is shared. We're going to draw a circle around these 2, showing that this pair of electrons gets shared. The fact that I have now not 1 circle between 2 atoms, but 2 circles between 2 different atoms, or between 2 of the same atoms, means that these are double bonded together. So this is what's called a double bond, because they're sharing 2 pairs of electrons. The same 2 atoms sharing 2 pairs. Okay, so on this slide, I want you to take a few minutes. I want you to draw carbon dioxide. I want you to draw nitrogen gas, which is N2, and I want you to draw hydrogen gas, which is H2. We're going to go over these in class and take a look at them, okay? As always, if you have any questions, write them down, ask in class.